Hi everybody, this is the lecture on section 4.1, which is the basic of differential equations. So, of course we have courses, entire courses in differential equations. There's two courses. There's ordinary differential equations and partial differential equations. But for those students that actually don't take those courses, this is just a short introduction, just so that they know some basic information about them. One moment. All right. So, definition. So, a first order differential equation is an equation using y prime, y, and x, where y is a function of x. A second order differential equation is an equation using y prime, y double prime, y, and x, again, where y equals f of x. So the difference here is that, y prime is the highest derivative of y, and here y double prime is the highest derivative of y, and so on and so forth, right, etc. Third order differential equation, fourth order differential equation, etc., etc. Okay? So given a differential equation, we say that y equal to f of x is a solution to it when f of x satisfies the equation. Okay, so for example, okay, y equals is y equal to e to the 3x a solution to the differential equation y double prime minus y prime minus 6y equal to 0. Is it a solution? So what we do is we plug the function into the equation and see if we get, 0 on the left, 0 on the right. Well, y is equal to e to the 3x. Y prime is 3e to the 3x. And y double prime is 9e to the 3x. So now, y double prime minus y prime minus 6y is equal to e to the 3x minus 3e to the 3x minus, y double prime is 9, that goes here, 9e to the 3x minus 3e to the 3x minus 6y, there's 6y, 6 e to the 3x, right, which is equal to 0, right? So it is a solution because it satisfies that equation. To this differential equation. Another example is y equal to x squared a solution to y double prime minus y prime minus 6y equal to 0. Okay, well here y is equal to x squared, y prime is 2x, y double prime is equal to 2. So y double prime is 2 minus y prime is 2x minus 6y squared, or 6y, is minus 2x, or minus 6x squared, which is not 0 for all x. Right, I mean, it's a quadratic polynomial and it might have a couple roots, so it could be equal to 0 at some point, but not everywhere. Right, satisfies the equation for all values of x. So this only satisfies for some values of x. Right. All right. All right. A general solution to a differential equation is a solution with one or more arbitrary constants. So a general solution is a solution with one or more arbitrary constants which account for all possible solutions to the equation. So, for examples, so consider the differential equation y prime equals 2e to the minus x plus 2x minus 1. Okay, we can solve this differential equation. It's just y prime equals f of x, right? Any solution to y prime equals f of x is of the form, right, y equal to capital F of x plus c, where capital F is an antiderivative of little f. Alright, so any solution to y prime, so this is the simplest type of differential equation you can have. Any solution to y prime equals f of x is of the form y equals capital F of x plus c. Right, that's an arbitrary constant where capital F is an antiderivative of little f, any antiderivative, and c is arbitrary constant. All right, so that's exactly the situation we have right here. Consider this differential equation. Y prime is little f of x. Find the general solution to the equation. Okay, so we're just going to take the antiderivative of that. So it's y equal to minus 2e to the x plus x squared minus x plus c. All right, so that's all solutions to that differential equation. And the only difference between two solutions is an arbitrary constant. And that's something just, a basic example of a differential equation. And something that we've been looking at in Calc 1 and Calc 2. All right, I mean, of course, things are going to get more complicated than that. Okay. Now, what about something like this? Give the specific solution to the differential equation y prime equals 3x squared y, given that y equal to a e to the x to the third is the general solution. Oh, I'm sorry. Give the specific solution of the differential equation. I didn't write that down right. Such that y of 0 is equal to 12. All right, think of that is f of 0 is equal to 12. But usually we don't refer to the function that is a solution to the equation. We just write it in these terms. Okay, so give the specific solution to this differential equation, y prime equal to 3x squared y, such that y of 0 is equal to 12. In other words, when x is equal to 0, y is equal to 12. When x is 0, y is 12, so give the solution that satisfies that, given that y equal to a e to the x to the third is the general solution to the equation, where a is an arbitrary constant. Okay, you don't actually have to show that this is a solution to that. It's given that this is a solution to that. You just have to find the specific solution satisfying this. Okay, so when we write y of 0 equal to 12, we mean y is equal to 12 when x is equal to 0. Right, so we have that 12 is equal to a e to the 0. So 12 is equal to a. So the specific solution is y equal to 12e to the x to the third. Okay? So given that general solution, the specific solutions, are figured out, but just plugging in the conditions that the specific solution satisfies. Okay. So what are some techniques used for solving differential equations? Well, I mean, there's various ones, but so aside from differential equations, of the form y prime equals f of x, we can also solve equations of the form y prime equals fx g y. So if it's a product of a function of x and a function of y, we can solve it as follows. All right, y prime is equal to f times g. So instead, write it as dy dx is equal to fx times g of x, or g of y. Move the y's to one side and the x's to the other. And then take the antiderivative of both sides. So when you take the antiderivative of both sides here, you should come up for a function for y implicitly in terms of a function of x. All right, so this will yield a solution to the differential equation y prime equals fx gy. So this will yield a solution to that, which is implicitly a function of x. Okay? So for example, let's take that previous example. Y prime is 3x squared y. How did we get that that's a general solution to it? So y prime equals 3x squared y. We want to solve this differential equation. And put the answer in general form. Explicitly for y in terms of x if you can. Alright, so this is dy dx, the y prime, and this is 3x squared y. So 1 over y dy is equal to 3x squared dx. Move the dx over here, the y over here. Now we can take antiderivatives of both sides. This is the natural log of y, and this is x to the third plus c. No need to put a plus c over here because you can always just move it over to here. So this, the sum of two arbitrary constants being an arbitrary constant. All right, but I would like to solve for y explicitly if I can. For x, if possible. All right, so that's an implicit solution. So let's see if we can't find an explicit solution. So e to the natural log to the y, natural log y, is e to the x to the third plus c. Right? I'm just taking the exponent of both of those. But e to the natural log of y is just y, absolute y. And e to the x to the third plus c is e to the c times e to the x to the third. Right? When you have the same base and two different exponents multiplied together, you add the exponents. Okay, because c is a constant, so is e to the c. So we might as well just call it a, just for some constant. And then y in absolute values, just means that y is either the positive or negative of that, but then positive or negative in an arbitrary constant is an arbitrary constant. So that's just b e to the x to the third, where b is an arbitrary constant. Okay? So that's just real quick basic introduction to differential equations. There's not too much in this section, but we'll move on from there this week. Okay? All right.